Hello all. We are starting with exercise 22D of probability. So in this particular exercise, we'll take up the problems which are having permutation and combinations. Okay. So the first problem, four digit numbers are formed by using the digits 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Using this, we are supposed to prepare a four-digit number without repeating the digits. Okay. So sample space. Now n is equal to 5 objects, r is equal to 4 places. So n of s is equal to npr, which is equal to 5p4. And if you calculate 5p4 on a calculator, it will be 120. If you want to use a box method for this, there will be 5 boxes. Okay, the first box can be filled up in 5 ways because there are 5 objects. Okay, now repetition is not allowed. So 1, 2, 3, 4, 5. So if one is already used, okay, over here in the first box. So now the number of objects left over here are 4, then 3, then 2, and then 1. Okay, 4 objects in the next box, then 2 are already used, then what 3 objects are left for the third box, so on and so forth. So you can also use a box method over here. Fine. So that is your n of s. Now the main event, if you read the next part of the problem, okay, event A is finding out odd number of 4 digits out of the objects 1, 2, 3, 4, 5. So see guys, okay. So the last box will be filled up with 1, 3 and 5 because we require odd number. So these are 3 ways. Okay. Now let us understand the first box. The first box can be filled up with 2 and 4. That is 2 objects plus, okay. There are 3 objects over here in the last box, but at a time only one will be utilized. 2 will remain. So 2 can be utilized over here, remaining 2, right? So 2 plus 2, that is 4. Now repetition is not allowed. This 4 will reduce to 3, 3 will reduce to 2, and 2 will reduce to 1. So n of A is equal to 4 into 3 into 2 into 1 into 3. Okay. So if you calculate this will give you 720, 72. Okay. And as per our standard probability, P of A is equal to n of A upon n of S. 172 upon 120 reduced fraction. So this will be, keep the answer in reduced fraction. So this will be 3 upon 5. Okay. This was the first problem. Second question. Okay. So basically we are supposed to find out the probability of getting 3 white balls in a draw of 3 balls from a box containing 6 white and 4 red balls. So there are 6 white and 4 red balls. In exam, you can write down the full form over here, white and red, right entirely. So in a draw of 3 balls, they are saying. So total is equal to 3. So n of s, sorry, total is 10. Okay, out of 10, we are supposed to pull out 3. So 10C3. Okay, so if more than one objects are drawn at a time, we can use combination. Okay, so this is the main theme of the problem, that is to draw 3 balls from a box containing 6 white and 4 red balls. But then out of this, which probability they are asking? All 3 balls should be white. So event A is probability of getting all 3 white. So 6C3, out of 6, any 3 white balls. Okay, so the required probability will be P of A, which is n of A upon n of S. You can calculate this 10C3 and 6C3 using a calculator. Okay, whatever value you get, and then the answer has to be in reduced fraction. Fine. Okay, third problem, question number 3. A bag contains 6 white, 7 red, and 5 black balls. So white are 6, red are 7, and black are 5. So this is a total of 18 balls. 3 balls are drawn at random. So n of s is equal to 18c3. Okay, selection of 3 balls out of the total 18. Now the event is that find the probability that all will be white. So n of A is an event of getting all 3 white. So white from 6, 3 white from 6 white balls. So that is 6c3. So P of A will be n of A upon n of S. Okay. Question number 4. Now question number 4, if you read the problem, okay, so basically here in this particular problem, a single marble is drawn. Okay, a single object, only one object is drawn. So no need of using combinations over here. You can solve this problem using simple probability and hence take it for self study. Fine. Okay, so next, let us go to question number 5. Now in question number 5, okay, we have to refer question number 3 itself, 4 itself for the data. So there are 2 white marbles, 4 blue marbles, and 6 red marbles. Okay, so now start reading question number 5. 3 marbles are drawn from the bag. So n of s is equal to, let us mention what are the total number of marbles. Those are 12. So 12c3. 3 marbles are drawn for the bag. Okay, so basically all 3 uh, should be from the same bag, and we are pulling out more than one object, so we are using combination. Now first part, n of a, all 3 should be blue. So 4c3. So P of A is equal to n of A upon n of S, right? Second, n of B. Let's name another event B, okay, where all 3 are red. Now this time instead of blue, we have to take red. B is an event of getting a red ball. So all 3 should be from the red category. So 6c3. Okay, so P of B is equal to n of B upon n of S. Okay, third part of the problem. All 3 should be white. Okay, now see, there are only 2 white balls. Okay, so there are only 2 white balls. So how can we take out 3 uh, white from 2 white balls? Okay, so all 3 cannot be white. One has to be of some other color. So the answer for the third sub question is 0, because this is really not possible to pull out 3 white balls from a total of 2 white balls, right? Let us go to question number 4. None of them is red. Okay, so not a single ball is red. So total red and non-red. So red are 6. Okay, so the non-red balls are also 6. So n of D. D is an event of getting not a single red. Okay, so 6c3, and P of D is equal to n of D upon n of S. That was sub question 4. Okay, then let us go to sub question 5. Not all of them are red. Okay, now this sub question can have cases. Case 1, not all are red. So case 1 would be one non-red and two red. Okay, case 2, two non-red, one red. Case 3, three non-red, zero red. Okay, there cannot be case 4 in such a manner that 0 are non-red and 3 are red, because all 3 cannot be red, right? So this case is not really making any sense. So these are the only possible cases, right? So not all of them are red indicates there can be one zero red, one red, or two reds out of the three, right? So how to write this further? One non-red, one non-red will be 6C1, and indicates multiplication 6C2. So 6C1 and 6C2, right? Okay. Two non-red, 6C2, and is multiplication 6C1. Okay. And the last one, 6C3 and 6C0. Okay. Whenever there are cases, there is always or between the cases, and or indicates plus. So this will be 6C1 into 6C2, that is case 1, plus 6C2 into 6C1, plus 6C3 into 6C0. This is P of E. E is an event where not all of them are red. Okay, this is N of E, sorry, and P of E is N of E upon N of S, right? Next, none is black. Not a single is black. Okay, so basically we are pulling out three balls and not a single is black. So all three will be from some other category, that is white or red. So I'll just list down what is black and non-black. So black are 4 and non-black are 8. Okay, okay, just a second. uh, in the problem, this B that I have written, this is blue. I'm sorry, I was thinking that this is black, so this is basically blue. So there is no black ball in this particular bag, right? So the probability of getting no black ball, okay, is 100%, because there is not a single black ball. So whatever three balls will be drawn, it will be from some the category of white, blue, and red. Okay, so there is no black ball, so probability of getting a black ball, it is almost not possible. So what is basically possible? The possibility of getting some other color ball. So all three will be for from some other category, that is white, blue, and red. Okay, so that is 100% chance, right? Let us go to the sixth problem. Question number six. Yeah. So two balls are drawn from an urn containing two white, three red, and four black balls, one by one without replacement. Okay. So basically, whenever they say with replacement or without replacement or one by one, okay, we have to use multiplication theorem. So we are not pulling out the objects at once. We are doing it one after the other, right? So the number of white balls are two, the number of red balls are three, and the number of black balls are four. Okay. First part, we are drawing two balls one after the other. So no combinations, guys. Do not use combination. Whenever they say one by one, do not use combination, whether it be with replacement or without replacement. So in this category, don't use combinations. Okay. So both the balls are of the same color. So case one, ball one, and ball two. So case one is for white. So the first ball being white, the chance is 2 by total. So that is 6 plus 3, that is 9. So 2 by 9, and is multiplication. Ball 2. Now the ball 2 should be also of the same color. And this is without replacement. So one ball is pulled from here and it is not replaced back in the on. Okay. So it will be 1 by 8. One white we have reduced. Okay. And the sample space is also reduced. This is called as multiplication theorem. Case 2. Both the balls will be of red. So 3 by 9, and second ball will be 2 by 8 because one red ball is removed from the bag. Okay. Case 3. This is for black balls. 4 by 9 into 3 by 8. So required probability will be case 1 or case 2 or case 3, and or indicates plus. So you can add all this. Whatever you calculate over here, you can add all this. Fine. So this will be 2 by 72, 6 by 72, and 12 by 72. Right. So 2 by 72 plus 6 by 72 plus 12 by 72. Okay, this you can calculate very easily on your own. Second part of the problem. Okay, again I'm going to write there are two white balls, three red balls, and four black balls. The total balls are six. Sorry, the total balls are nine. Okay, they are asking the probability of getting at least one red ball. Okay, so case one, red, non-red. So at least one. This should be at least one. Okay, so one red and two non-red, one red and one non-red. Sorry, because we are drawing only two balls. Okay, case two, two red and one non-red, two red and zero non-red, because both the balls will be red, so there will be zero non-red. Okay, now any other case which is pending over here? I don't think so. Okay, so the answer for this will be, no, probability of getting one red out of three. Okay, so that will be 3 by 9, 3 out of 9. Okay, now the sample space will reduce because this is one after the other without replacement, and the other category will be non-red. So the non-red will be total 6. Fine. Okay, so I'll just explain this once again if you are not able to understand. The condition put is like we need the probability of getting at least one red. So there are two balls which are drawn. So there can be one red or maximum two reds. So when we are saying one red, the other ball will be from non-red category. Okay, and second case, if there are two reds, the other category will be from non-red category, which will be zero non-reds. Okay, now see case 2. While solving case 2, the first ball being red is 3 by 9, and the second ball being red is 2 by 8. The sample space will also reduce, and the number of red balls will be reduced by 1. Okay, so that's how it should be. Now here we have to think in some other perspective as well. When I took case 1, the first ball was red, the second ball was non-red. Or case 2, both are red. Or case 3, the first one is non-red and the second one is red. So this perspective also we need to take into consideration. Okay, so we'll take case 3 as well, because the order is also important in such kind of problems. So this will be non-red and red. So the non-red will be first, will be non-red, and the second one will also be non-red. So probability of getting first non-red is, there are total 6 non-red balls. So 6 out of 9 into the second ball will be red, and that red ball is 3 out of 8 because the sample space got reduced. Okay, so you can add all these cases to get the final answer. Fine. Okay, so let us go to the seventh problem. From a pack of cards, 3 are drawn at random. So n of s is equal to 52c3, right? Find the chance that they are king, queen, and a knave. Knave is a jack. Okay, so n of a, one is a king, so there are 4 kings. Okay, and one is a queen, 4 queens, and there is one knave. Okay, one jack out of 4. So p of a will be n of a upon n of s. That was your question number 7. Fine. Question number 8, sub question 1. Okay, so let us understand this particular question. 2 cards are drawn at random from 8 cards numbered from 1 to 8. Okay, so n of s is equal to 8c2 because there are 2 cards which are drawn out of 8 cards. Okay, fine. So what is the probability that the sum of the numbers is odd if the true two cards are drawn together. So we'll just note down the cases. So 1 along with 2, the total is 3, the sum is odd. 1 along with 4. Okay, and see, both are taken together. Okay, that means 1 comma 2 and 2 comma 1 means one and the same thing, right? Okay, so this you need to consider very well. Okay, then 1 along with 6. 2 and 1 we need not count it once again. 2 3, 2 5, 2 7. Okay, I missed out on one thing. 1 8 is also there. Okay, 2 3, 2 5, 2 7. Then 3 3 2, 3 2 is already done. 3 5, 3 5 will give me 8, sorry. 3 4, the total is 7. Okay, then 3 6, right? Then 3 8, there are total 8 cards, right? So 3 8 is 11. Now let us consider 4 4 5, 4 7. Okay, these are the numbers in 4. 4 1 is already considered, so no need to do it once again. Then 4 5 4 7, right? 5 2, is 5 2 done? Yes, 5 2 is already done. 5 4, yes, 5 4 is also already done. 5 6 is not done, so we'll consider that. 5 6, the total is 11. And remember, for this problem, 5 6 and 6 5 is one and the same thing because the two cards are drawn together. Okay, then 5 8, right? 6 7. Okay, 6 1 6 3, 6 5 already done. Okay, then 7 along with 8. So these are the possible events where the total is odd. So P of A is equal to, so this is N of A, sorry. Which is 16, and P of A, naturally it is N of A upon N of S. Okay, so count the total number of events very clearly. Okay, take your own time, don't be in a very hurry to finish it off. Next problem, sub question 2. Two cards are drawn from a well shuffled pack of 52 cards. Okay, show that the chances of drawing two aces is 1 upon 221. So N of S is equal to 52C2 because we are drawing the two cards at once. N of A, the two cards should be aces. So there are four aces. So P of A is equal to 4C2 upon 52C2. You can check whether this is 1 upon 221. Okay. Question number 3. So from a pack of 52 cards, 3 cards are drawn at random. So n of s is equal to 52C3, right? So exactly 2 aces. So 3 cards are drawn at random. That means that they are drawn together. It's not one after the other. Okay, it's together, right? So whenever it is together, we use combinations. So exactly 2 aces. So there will be 2 aces and 1 non-ace. So there are 4 aces. Out of 4, 2 are to be drawn. So this will be 4C2 and is multiplication. 1 non-ace. 1 non-ace will be 1 out of 48. Okay, so 48C1. So let this be n of a. Okay, so p of a is equal to n of a upon n of s, right? Third question, read the question clearly. Third is done, sorry. This is question number 4. 3 cards are drawn at random at a time at random from a well shuffled pack of 52 cards. Find the probability that all the 3 cards have the same number. Okay, so basically n of s is equal to 52C3 because we are drawing 3 cards. Okay, now all the 3 cards will have the same number. Case 1. Okay, so when I talk about the 3 cards of the same number, so basically every suit has 13 different categories. Okay, for example, hearts. So there are 13 different categories from 1 to 10 and 3 face cards, right? So case 1, all 3 will be aces. See, don't get confused over here that they have the same numbers. They have the same number indicate that the 3 cards will be of the same category from each suit. Okay, so all 3 will be aces. So there are 4 aces. So out of 4 aces, any 3 can be pulled out in 4C3 ways, right? Case 2, all 3 will be having number 2, right? So there are 4 number 2 cards. Okay, so all 3 will be from this 4. So this will be 4C3. Okay, see, we have to go ahead with all 13 categories. Okay, so because the 3 cards should have the same number. So n of a is equal to 4C3. This is for 1 plus 4C3. This is for 2. That is case 2. Okay, case 2 has which category? All 3 cards should have number 2. Case 3 is for 3. Okay, so that is also 4C3. This will be 13 times because there are 13 different categories from ace to king, queen, and jack. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, king, queen, and jack. So 13 times. So this will be 13 into 4C3. So P of A will be N of A upon N of S. Okay. Next question. Question 5. Two cards are drawn from a well shuffled pack of cards without replacement. Okay, find the probability that neither a jack nor a card of spade is drawn. Okay, now see, the word without replacement over here creates a confusion, so you can please remove that. Okay, so two cards are drawn at once. That is what we will consider. So n of s is equal to 52 c2. Okay, n of a. Now we don't require a jack, right? And we don't require spades. So there are 13 spades which are gone. Okay, so total out of 52, we are reducing 13 spades. So now we are left with 39. And we don't require jacks as well. Now one jack is already included in this spade. Okay, so we are left with three more jacks. Now these three jacks are also not allowed. So we are left with 36 cards now. So the two cards drawn should not be spade as well as jack. So we have to select from 36 cards, 36 C2. So P of A will be N of A upon N of S. I hope you all understood. Okay, let us go to the next problem. Question number 9. Three cards are drawn from a deck of 52 cards. N of S is equal to 52 C3. Okay, what is the probability that they all are spades? So N of A, there are 13 spades, so 13 C3. So P of A is equal to N of A upon N of S. Second, all are red cards. Okay, so basically there are 26 red cards. So let event B or is an event of getting all red cards. So 26 C3, all should be from the red category. So P of B will be N of B upon N of S. Third one, okay, none of them is a club. Okay, so how many non-clubs are there? So the total number of non-clubs are 39. Okay, so N of C is equal to all three cards should be from non-clubs, that is 39 C3. Okay, so P of C will be N of C upon N of S, right? And the fourth one, all of them are aces. So the total number of aces are 4. So N of D is equal to 4C3 because we are drawing any three cards. So all three will be from the aces category. So it will be 4C3 upon 52C3. N of A upon N of S, right? Okay, now let us proceed further. So basically we need to understand this. Odds in favor is equal to success upon failure or probability of success upon probability of failure. Okay, and odds against a particular event is failure upon success. Okay, so let us solve question number 10. Question number 10 says you have to consider question number 9 and you need to find out what are the odds that all three cards are spade. Okay, now in question number 9, first subpart, P of A. Let me go back to the previous slide. P of A. Okay, so P of A, if we calculate this, okay, so I'll just write down the answer. It will be 11 upon 850. Okay, this divided by this 11 upon 850. Okay, now what we will do is we'll calculate P of A dash, that is 1 minus P of A. Okay, right? So that will be 839 upon 850, right? So the odds in favor of this particular event, P of A, we had got 11 upon 850. P of A dash is equal to 839 upon 850. So the odds in favor will be P of A upon this divided by this, P of A upon P of A dash, 11 upon 839. Okay, second part, 10 sub question 2. P of B, all of them are red cards, so we need to find out odds of this. So we'll go back to question number 9. P of B, 26C3 divided by 52C3, we had got this as 2 by 17. So P of B is 2 by 17. P of B dash, 1 minus P of B, 15 by 17. So odds in favor of this particular event is equal to P of B upon P of B dash, 2 by 17 upon 15 by 17. Just cancel this out, 2 by 5. So similarly, you can also solve third part and fourth part. The question is related to question number 9, but then in question number 10 they are asking odds, and in question number 9 they were asking probability. So odds of a particular event is nothing but odds in favor of a particular event. Okay, question number 11, you can take it for self study because it's a very simple problem. Okay, so in this problem only one card is pulled out, so no need of any combinations and all. You can try it for homework, right? Let us go to question number 12. Okay, it's quite extensive. Question number 12, let's focus on this. Yeah, 4 cards are drawn from a well shuffled pack of 52 cards. So n of s is equal to 52c4. All 4 cards should be from the same suit. So there are 4 suits. So case 1, all 4 from spades. So 13c4, or case 2, all 4 from clubs. 13c4, or all 4 from hearts. 13c4, or case 4, all 4 from diamonds. So this is also equal to 13c4. So 4 out of, see there are 13 spades. Out of that we have to pull any 4 cards. Okay, it should be from the same suit. Okay, so this is just case 1. Likewise, there are 4 cases. So n of a is equal to 13c4 plus 13c4 plus 13c4 plus 13c4. You have to add the answers for all the cases. Okay, and naturally P of A will be N of A upon N of S. Question number 11, sub question 2. I'll just write down N of S. N of S is equal to 52C4. Okay, all four cards will be of the same number. Okay, all four cards will be of the same number indicates. See, now same number we have discussed it some time back, right? So basically same number indicates 1 to 10 and 3 face cards. So case 1, all four from number 1. So there are four number 1 cards, or rather there are four aces. So this will be 4c4. Okay. Case 2, all four from number 2. So there are four number 2 cards. So 4 out of 4. Okay. Case 3, all four from number 3. So there are four total number 3 cards. Sort of 4 we have to pull out any 4. So 4c4. Now this will go on for 13 times because there are 13 different categories. Okay. So N of B is equal to 13 into 4c4, and P of B is equal to N of B upon N of S. Next question, sub question 3. Okay, one card from each suit. First of all, N of S is equal to 52c4 because we are pulling 4 cards from 52 cards. Case 1, one from, there won't be cases because we have to choose 4 cards but such that one from each suit. So one from spade and one from club and one from diamond and one from heart. So one from spade can be selected in, let this be N of C. Okay, one from spade can be selected in 13c1 ways, and one from club, there are 13 clubs, right, can be selected in 13c1 ways. One from diamond can be selected in 13c1 ways, and one from heart can be selected from in 13c1 ways. So P of C is equal to N of C upon N of S. Okay. Fourth problem, fourth sub question I mean. So N of S is equal to 52c4. There are two red cards and two black cards. So two red and two black. Two red can be selected in 26c2 ways, and is multiplication. Two black can be selected in 26c2 ways. So let this be N of D. Okay, so P of D is equal to N of D upon N of S. Fourth one, fifth one, all cards of the same color. Okay, so this will be 4 red or 4 black. So N of E this time will be 4 red. So 26C4. Now or indicates plus 4 black. So out of 26 there can be any 4 cards which are black. Okay, and or indicates plus. So N of E is 26C4 plus 26C4. Right? Okay. P of E is equal to N of E upon N of S. Let us go to the sixth problem. Sub question 6 I mean. N of S is equal to 52C4, that we all know right from the beginning of the problem. all will be face cards. So let us count how many face cards are there. King, queen, jack. Okay, king, queen, jack. These are three face cards, and there are four categories. Okay, spades, clubs, diamonds, and hearts. So n of, let's say, f will be each category is having three face cards. Okay, so four categories will have 4 into 3, which is 12 face cards. Okay, so n of f will be 12c4, right? So there are total 12 face cards. So out of 12 we have to select any four cards, and p of f is equal to n of f upon n of s. Okay, next one, sub question 7, four honors of the same suit. Okay, so basically honor cards, let us understand what are the honor cards. King, queen, jack, and ace, these are the honor cards. Okay, so total, first of all I'll write n of s, which is common for the entire problem, 52c4. So four honor cards of the same suit. So first category, let's say club. So there are four clubs, right? So we have to select any four out of four, because total at random we are pulling out four cards. So four cards are pulled out of four honor club cards. Or I'll say or, right? Spades. There are four honor cards in spades. So out of those four we have to pull any four. Or diamonds. Again this will be 4c4, because there are four honor cards in diamonds. So out of this four we are pulling out any four cards. Or hearts. Four honor heart cards. Out of those four honor heart cards we are pulling out any four. Fine. So n of, let's say, g is equal to 4c4. Now this is or indicates cases. Okay, so these are four different cases. Okay, so n of g is this, and then p of g is equal to n of g upon n of s. We'll proceed with the next problem, that is question number 13. Okay, in a lottery of 50 tickets numbered from 1 to 50, two tickets are drawn simultaneously. Okay, so find the probability that both the tickets are having prime numbers. Okay, so basically drawn simultaneously indicates together. Okay, okay, back to back but together. Yeah, so n of s is equal to 50c2. Two tickets are drawn, right, out of 50. First part, both are prime numbers. So let a be the set of prime numbers: 2, 3, 5, 7, 11, 13, 17, 19, 23, then 29, 31, 37, 41, 43, 47. Okay, so n of a will be, these are total 15 objects. So 15c2, 2 will be prime. Okay, so any two prime out of 15 primes. So p of a is equal to n of a upon n of s. None of the tickets drawn has a prime number. So basically, see, if there are 15 prime numbers out of 50, so there will be 20 prime numbers. There will be 35 numbers which are not prime, right? So n of b is equal to 35c2, because we require two tickets which are not prime. So p of b is equal to n of b upon n of s. Okay. And the third part, they are asking for A ticket has a prime number. A ticket has a prime number. So one prime number ticket and the other will be non-prime. So one prime out of 15 can be selected in 15 C1 ways, and one non-prime out of 35 can be selected in 35 C1 ways. So this is N of C, right? So N of C is equal to 15 C1 into 35 C1. So P of C will be N of C upon N of S. Okay. Next question, that is question number 14. Out of 9 outstanding students in a college, there are 4 boys and 5 girls. So there are 4 boys and there are a total of 5 girls. Okay. Total is 9. A team of 4 is to be selected for a quiz program. So N of S is equal to 9C2. Okay. So this is the sample space. Find the probability that there are 2 girls and 2 boys. So main event A, we require 2 boys and 2 girls. So 2 out of 4 boys can be selected in 4C2 ways and 2 out of 5 girls can be selected in 5C2 ways. So this is N of A. So P of A is equal to N of A upon N of S. This was the first sub question. Okay. Next sub question of question number 14. 4 people are selected at random from a group consisting of 3 men, then 2 women, 2 women, and 3 children. So this is total, let's say 8. Okay. The crowd is of 8 students, 8 individuals. Sorry. So 3 are men, and then 2 are women, and 3 children. So we are requiring 4 people at random. So N of S is equal to 8C4. Now exactly 2 children are required. So N of A is equal to 3C2 and the remaining 2 will be from men and women. So 5C2 and P of A will be N of A upon N of S. Okay. Then let us go to question number 15. A committee of 5 principals is to be made from a group of 6 gent principal and 8 lady principal. So gents and ladies, this is 6 and this is 8. Total is 14. A committee of 5 principals is to be made. So N of S is equal to 14C5. Okay. Find the probability that there are 3 principals, 3 lady principals and 2 gent principals. So N of A, we require 3 lady principals. So 8C3, and out of total 5 principals, if 3 are ladies, then naturally 2 will be gents. 6C2. Okay. So P of A will be N of A upon N of S. Right. Question number 16. A bag contains tickets numbered from 1 to 20. 2 tickets are drawn at random. So N of S is equal to 20C2. Right. Both the tickets should be odd. So from 1 to 20, okay, there are 10 odd numbers. Okay. So N of A, both the tickets should be odd, right? So out of 10, we require any two. From 10 odd numbers, we require any two odd numbers because both should be odd. So N of A is equal to 10C2, right? So P of A is equal to N of A upon N of S, right? Yeah, that's it. So I think you can prepare all the 16 questions, okay, for the exam. Thank you.